If there's a change in direction, you've got vector acceleration.
Right, okay.
So
But is there, okay, so velocity is not constant because there's a change in direction, but that change in direction is constant, so therefore it's a constant delta V, so acceleration.
Actually, no, because if I'm traveling in a circle, at this, let's say I'm going in this direction. At this point right here, that's the direction I'm moving in. At this point right here, that's the direction I'm moving in.
Right.
So if you look at the change, if this is VI and VF. That's the change right there, that's delta V.
Right.
If I'm over here,
I know where it is.
and then like that, my
It's in
change
the
in
car.
direction is that way. So that and that do not have the same direction. They're both towards the center, so we can easily say it, but officially that is down and that is to the right.
So then wouldn't that mean non-constant acceleration?
That would be.
Yeah. Oh, so it is possible to have it's not possible to have constant acceleration in a circle?
You would not have constant vector acceleration.
Okay.
Let's see, Tatiana. All right, so we have a test on Thursday. Questions? As in, are there any? Okay. What's the last thing we did?
We finished, directional forces.
What's the last?
Force diagrams.
We did, oh, sorry, I ran through an example of that. The force diagram I did before that was what the box on ramp.
Yeah.
Okay. Let's continue our quest with the force diagram leading up to something that's test level. All right, when I draw these, it usually looks like that top angle of the wedge is about 90 degrees. Please don't assume that. That's just like the acute angles almost always look like they're somewhere around 45 degrees. It's just the way I draw it. Come on. Live. All right. Zip through a force diagram. There is a piece of information missing, which we'll get to.
Could you change the letters so that it's not two capital A's and two capital B's? Because that's gonna screw with me.
I don't have. You mean?
The one box is A, one angle is A. One box is B, one angle is B, and they're all capitalized.
You want lowercase?
Yes. I want 2 in lowercase.
The trouble with, you can't really do lowercase a, because that's acceleration. What, do you want a lowercase b? All right, doing the force diagram, first step in Facades method. So we got F tong as my checklist. Can we get rid of anything?
We can get rid of others.
Yes. And that's it. Let's do friction last, because that's some comments to make on that. All right.
Okay.
Let's start out with what I find the easiest one, gravitational force. In which direction is the weight acting on what? Assume ideal pulley and rope.
Ideal pulley and rope, you said?
Yes. Roughly, this is the easiest one.
The force of gravity is pulling down on box A.
Down on A.
And box A is pulling up on the ground.
And again, the wedge and the ground are part of the same thing here. If you want to draw the arrow here instead of here, that's fine. All right, one down.
Same thing on box B. Gravity's pulling down, box pulling up.
Okay. Anything else with a weight?
Is gravity pulling, the force of gravity pulling down on the rope too?
If you put that in there, I wouldn't take off for it, I would just ignore it. It's an ideal rope, so no, it would not. In reality, yes. Do you want me to put it on there?
It's okay. Okay.
So we're done with that. Next. Tension. Which way is tension acting on what?
Rope is pulling on box A. Pulling it, towards,
Okay, pulling up the rim.
yeah.
So I got my tension here.
The box is also pulling the rope itself towards it.
Tension there.
And then the same thing with box B.
Like that. I got tension there. Tension there. All right, I have one rope. We've taken care of both ends, so done. Excuse me. If I look at these forces in terms of going from left to right of 1, 2, 3, and 4, which two would have the same subscript? If I put the subscript in there.
2 on the left would be one batch and 2 on the right would be the other batch.
Okay? Yep. Normal.
One would be pushing on the ramp would be pushing back.
So you're doing
Box A.
A, pushing on the rim?
Yeah.
Pushing back.
And then same thing with box B.
I'm sorry, put a lowercase here. All right, friction. Since I have like only the two masses, yeah, Oh, wait, no, there's another paranormal forces. Yes. They are touching. There's a reason the rope is bent. If the pulley were not there, that thing would straighten out. So we do have the pulley pushing up in some direction, upwards, wise, I'll go with P. Wise and P. All right, that's it for contact. Normal, notice the one we just did. Friction. Which way is friction acting on what?
Technically like this.
Okay.
A is trying to go that way, and the ground is pushing it this way.
So you're having friction on box A downward, down and to the left.
Yeah.
Okay.
Wait, so
Everyone okay with that?
which way did she say? Can you repeat
She
that?
said it would be going that way.
No,
What do you say?
the other way. Are we
No,
talking about the?
That's not what I said.
Oh,
Said down and to the left on A.
So this would be going.
So
So,
that's on the ground, it's going down and to the left?
yeah.
On the box, it's going up and to the right. Okay.
Because
That-
it's trying to go that way with the box B.
Is that what you're saying?
no, isn't the box is trying to go
Is it the reverse?
down
Yeah, both boxes.
because of like gravity. The thing that's keeping it up is the rope.
Oh.
So
So
I'm-
they're the same way?
So the box is going, I don't know how to put it into words like Talon does, but the box is going this way, and then the ground is pushing it up this way.
So the boxes
So-
are
Or
the same
ramp,
way?
sorry. Yeah.
Boxes are not the same way. So, but you're making a proposal that on the boxes, it's going down like that?
Mm-hmm.
All right, it really comes down to which way is this thing gonna go? This is the information I left off.
Can it be assumed that the rope is in the exact middle point where it's in the middle point of the pulley?
No.
So one side can be longer than the other?
Yes.
Okay.
In order really to know which way this has a desire to move, we would need to know the two angles and the two masses. I did not give you that information, so it could be this way, or it could be the reverse of it, and over here, it's gonna go one way or the other, if at all. It is also possible that it is so perfectly balanced that there's no friction at all. We'll work through a problem like that, hopefully today. So I need to give you more information, since that's already drawn there, let's just go ahead and assume that it wants to go this way. But, again, I would need to give you more information for you to determine. And since it's 151 and not 110, you will be able to figure it out at some point. Therefore, which way is friction acting on mass B?
If my theory is correct, then it's trying to go that way, and so friction would be pushing it that way.
All right, it's a tight rope. It doesn't stretch.
Is it dragging the other box? Because that's what I think is happening.
Is it dragging the other box? As in, is B dragging A?
Yes,
If B is dragging A, then A is going that way.
yes, that's what I think is happening in my
Then that
head.
arrow would go the other way.
Okay,
Friction opposes the motion.
okay.
So, if for right now, if I'm just saying that this is the way that it would tend to go, if it were frictionless, it would go this way, then friction would act that way on A. And, well, if this is going down, B wants to go up, it'd be acting this way on B. No, lowercase. Or what's the question?
Okay, so is the ground what is the ground doing for A?
What is the ground doing for A? Well, it's applying its normal force to keep it from falling,
Okay.
or swinging that way, and it provides this weight which makes it want to
But I
go down
want like
right.
the friction.
Pardon?
Like the friction when why? No, actually I understand what you're doing. I was just confused for a second.
Christian, are you well? Whichever one's appropriate here.
We don't know. So we decided.
Questions?
We decided that A is heavy. No, wait, what? I thought we decided.
Okay, it's time.
That would be Oh, yeah. I was like,
I'll draw
I was
this
like,
here.
when did we get
I was going to erase that so that we have room to work over here. Any, still ready? All right, the following is a test level problem. Not to scale. That's probably good enough. All right, so I need to tell you that they are accelerating to the right. They're accelerating to the right. And he does this by pulling back on the stick straight towards him. So there's a stick accelerator there, which I put into a number of my problems because it's just a lot simpler than holding the steering wheel. Then I have to tell you how he actually grips the steering wheel, etc. So, in order to accelerate forwards, he's pulling the stick back towards himself. Boy's sitting on sled. Sled's being pulled by this rope, which is attached to a box sitting on top of this vehicle. It is 4-wheel drive. I guess not a decimal for 4. So we'll have the boy. We'll have sled. We'll have ground. We have rope. Box. Vehicle. Chair and driver. Or my scenario, dad. All right, I would definitely break it up for you so that you're not trying to guess what is part of what. I am going to move him a little bit farther away for a little bit more room. Oh, that's good. Got that done. All right, test level problem. I sometimes wonder if, I've done this once, and I don't know if it made any difference at all, where I didn't say how many forces were on the diagram, but I did say that if you want to know, I'll be glad to tell you. And it's that double-edged sword of, let's say you have 34 forces and there's 36, now you're left with this quandary of, do you hunt down for the last missing pair, or if you have 40 and there's 36, which ones did you overshoot? You have 5, and it's 36. Then you probably shouldn't waste any more time on it. Anyway. So probably on the test, if you wanna know how many forces, I'll tell you if you wanna know. FCOM. Can we eliminate anything?
I don't think so.
Other?
Yeah, we can get rid of other. Oh, that was simple. There we go.
Yay,
Next. Ideal route.
oh, I do rope. Does change anything for you? We start with gravity, show the forces of gravity.
Okay, acting on what?
Okay, so the ground is pulling down the sled, right?
Pulling down on the sled?
Yeah, it's pulling down. The force of gravity is pulling down the sled. I apologize.
So I have weight of sled.
And then the sled is pushing up on the ground.
Ooh.
I mean, pulling. I don't
Yes,
know.
they,
There you go. Pulling up on the ground?
yeah.
Okay. So I don't want to think the word.
And
Pushing down.
I saw this on
Pushing
the,
up, yeah.
on the master set recently. I mean, people putting, oh, sorry, it's 110. On the master set, putting the areas right next to each other in no man's land. Please don't.
Yeah.
All right, one down.
Uh,
We have to do